Okay, so we have Tammy Gammon, Robert Arno, and Mike Anthony, and Tammy will be talking about her data collection plan. Go ahead. Oh, today is November 1st. Go ahead, Tammy.
Okay, well, first of all, if we could just kind of start off at the beginning. What I did is I presented sort of three different types of commercial building studies depending on where the funding comes from. And I'm assuming that's fine with everybody. I just thought that kind of left the options open. And I'd appreciate, Mike, if you would also participate in this because I know this is ultimately really your airplane.
Yeah, sure. I'm running so many airplanes right now. But it's deferent to your expertise and the professionalism. So yeah, I'm participating.
Okay, so I just wanted to talk, like, informally, just to get your ideas and concept of how you put this together in terms of your three different building selection options and your approach to the data collection.
Uh-huh.
So I just wanted to get some details I guess the first thing is you want to monitor for a year in each one of these facilities, correct?
Correct. I thought from what we talked about before that that's really what was required to have really good data.
So are you going to be using a type of system that will report back periodically and download the information? Or is this going to be a system where it's going to be recorded on site and you'll have to go back to site to record the data?
Okay, what I was assuming, that also depends on the option chosen, but what I'm assuming is we're just going to have on-site data recorded and that site will upload the data to some kind of internet site that I say we as I'm going to be involved, but I'm not. I'm just saying we because I'm doing the plan, but that we'll have.
You don't want to be involved with the collection part of it?
Oh, I would like to be, but I think that's rather presumptuous of myself. I mean,
okay.
No, I would enjoy being involved, but I haven't been asked to be involved, so I'm just, trying to do this for you.
Okay.
That's part of what my phase two charm offensive is, taking this and building the case for funding either by government or another consortia. So
right.
It is important that we do it economically. And frankly, when Bob said, Bob's done a lot, probably the first name in data collection, at least for the Army and the Department of Defense, that these organizations, his expertise can be brought to bear here. So everything that's said here is probably, just keep in mind, it's likely something we would use as a record of work for those who would be funding a phase two. Go ahead.
Right. Okay. Can you tell me exactly what you're going to what assets that you're going to put this measuring systems on and record information?
Well, that depends on the site selection, and I'm waiting for feedback basically from the sponsor group, because if the university does it, they've been telling me that basically a lot of their loads are already metered. And so if we could use in-house metering equipment, then that would significantly reduce the cost. And that's kind of the direction I was waiting for, is should I be looking for some sort of metering equipment? And if so, I know that people would like something that you permanently install. They don't need, this isn't like you're going to go and take a spot measurement and you're going to have wires all over the place. It's going to have to be non-invasive and part of the system, and then the data collection from that is going to be something that I'm not really familiar with, but I'm assuming that what's going to be required is that they're going to have to download the information from the metering equipment and then upload it to me. It's not going to be some kind of a wireless study. I was reading about wireless plug load studies, but that's an entirely different thing. I don't think that's something that we would want to do, to go into a number of commercial buildings and try to not only install metering equipment but the whole wireless metering system. And part of that, the data collection, is the frequency of data collection. And I was thinking for our site probably like 15 minutes would be suffice. Some of the plug load studies, it was I think on even as frequently as 10 seconds.
Yeah, I suspect that when you get into a campus type of arena, like a large college, like where Mike is coming from, they'll have a SCADA system that will monitor energy levels and power flow. But I also suspect that it won't be too much below the 480 or maybe even a little bit lower than that, that you'll be able to monitor the power flow. So that's why I was asking what assets, what components that are you targeting to put the measurement equipment on, or information.
Well, what's really that's something I have to work on. What's really interesting is I was reading, I think it was ASHRAE 90.1, and I guess you don't know either, but I couldn't believe it. Monitoring equipment is actually, well, I guess metering equipment is a better word than monitoring. Metering equipment is actually required on all subloads, and I mean that includes lighting, receptacle, and HVAC. They had a list, and I was really surprised. So apparently the equipment exists as part of standard packages and is being used in the few places around the country that are actually following the energy codes to the letter now. And not only that, is they actually have automatic shut-off for receptacle load, which I was surprised. I think it's like 50% of receptacle loads under some conditions and 25% for others.
No, just some background. No, I pushed them back on, that's largely for commercial office buildings. I pushed them back. They were trying to do that for student residence dorms, dormitory rooms, and for classrooms, both of which we pushed back on. And that doesn't mean that under their continuous maintenance system they didn't come back. And it's probably fair to say that if I wasn't vigilant, the incumbent interests are going to try to sneak that in there. So it is what I call over metering. And I don't know which version, but if you could send me those passages, is that from a more recent version of 90.1 you're talking about, Tammy?
It's either going to be the 2013 or the 2016 with corrections. I haven't purchased it yet, but Eric Richmond from Panel gave me something that probably shouldn't be shared just for me to look at, but I can just send you the passages I was looking at. Okay,
good. So, no, they might have snuck it in 2016, but I know I pushed back on 2010 and 2013. But again, those folks, they work in 30-day time frames, and it's possible that something snuck in. Okay, that much said, what I was going to recommend is that we identify the low-hanging fruit, in my mind, would be a service substation with newer feeder breakers that actually can be identified as being all lighting load or all 208 120 volt load, and that would be low-hanging fruit. As we know, the services are fairly well understood, and most of the new substations do come with feeder breakers, 400-800 amp feeder breakers that have metering data on it. In most cases, we paid a lot of money for data that's not changing behavior one whit. But that much said, we can use that data, and it would be relatively simple for me to send up a trial balloon and asking who would be willing to spend time downloading and getting us a sense of participating colleges and universities that could get us that data. And then, of course, you would break it up a little bit. The 480, the lighting load is probably likely easiest. It's probably the purest load. But if you have, let's say, a 400 amp, 480 volt breaker that's going to a 208 120 downstream, that'd be a large one, downstream transformer that are transforming for plug loads, and maybe some smaller fan coil units at 208, that would be relatively easy data to get. Not that it's that easy, but it saves you from having to buy recording ammeters and such and so forth. So I can probably get a first cut on that relatively soon. But and that doesn't limit us to 50 commercial buildings, but it gets us a sense of an overview of what's possible. What do you think about that?
If you're asking me, I think that sounds like a good idea. And also, if you could connect me to someone who deals with metering, because unfortunately I really am an analysis person, and I just don't have a lot of real experience for selecting meters and things like that, so that I can be more familiar. So if you can have someone point me in the right direction and I can start reading about the specific equipment that you'll need, I'd really appreciate it.
Okay, so I have a couple questions. They're probably stupid questions, and I apologize in advance for asking the questions. But is the purpose of this plan to look at the load characteristics of the transformers and to determine overall and on overall various environmental conditions what the average load is on these transformers versus its capacities? Is that true?
That was one of my goals, because I thought if you're going to, if we're going to conduct a massive data effort, that part of the overloading is also on transformers, and if we could have some kind of real data on what's going on with transformer loading, I thought that would add to the benefit of the project.
Well, to me, looking at I'm looking at the practical aspect of the project and how accurately or how efficiently we can collect the information. I mean, because there are some lighting loads that are mixed with other different types of loads too. I mean, in the older facilities and buildings, how things change. But to me, it seems like if we can get to the information on each one of the transformers inside a facility, the ones you've identified, I think, oh, by the way, are good size, good good variation and identification of the different areas. But if we can get to the transformers and indicate, take all the information and try to get a capacity versus load characteristic over a period of time, I think that would be extremely beneficial information and a telltale sign of the different types of loads that are associated with these transformers. That would be my thought.
I would expect that in the early part of the life cycle of a building, let's say in the first 5 years, that those transformer building I'll call downstream distribution transformers are fairly pure, meaning that if you're getting a breaker that's fed out of the substation feeding lighting loads, 277 volt lighting, that it's likely to be nearly all pure lighting, because it's rare to see fan coil units and other HVAC picked off of lighting.
Okay.
But also, that's
not what I see, but I'm also dealing with buildings that are much older than that.
That's right. And so that's what we have to deal with now, even age of the building. So that's why just getting a bird shot of what might be possible, how old the building is, even how old parts of the building are, is important.
Right. And I also don't think that you're going to be, again, I'm basing these comments on my own experience on older facilities and also on government facilities, but also including hospitals and some of the industrial applications. If you're looking for if you're looking for a comprehensive monitoring system, I don't think you're going to find one. Only in the newer facilities, only in the very large facilities where energy is a factor in terms of operating efficiency. I know there's tons of government mandates. I know of only, at this point in time, I know of only 3 different sites that I know monitor their energy efficiency and for their entire complex, right down to the room itself in different buildings. And one of them is in Fort Meade, and one is in Texas, and one is in Utah. And you'll never get that data. I'm sorry.
Well, that's just really interesting to know. Well, just to add to talk about transformers, I just have a question for you. One thing I included in the plan, which might be unrealistic, was also to add like harmonic and well, I guess harmonic monitoring would be enough. I was thinking K-factor, but you can just determine that from the harmonics. But even if we couldn't continuously monitor that, I think even spot checking would be good. I wondered if you thought that would be beneficial, because part of transformer loading is harmonic levels. And
yes, that's extremely true. And I you know, that although it wasn't originally a focus on this particular project, I think that's a very good point to bring up, to do spot checking on harmonics, especially in certain types of buildings, you know, industrial application. Not so much. Well, I don't know. Maybe office buildings would be one I'd want to check too. But you're right. It could cause. I know I've done some forensics on transformers at different areas out in the Southwest, and harmonics has caused a catastrophic event in those transformers.
Well, supposedly lighting and receptacle load is high in harmonics, and it's not something that I've really seen, because I've done quite a bit of work with lighting systems, and it seems like when you see new lighting systems designed, they're all, you know, very low in harmonic generations, but when I read the literature, supposedly it's reported that they're high, so I think it would be good to have some solid data. Another thing is it'd be very good to see, we're looking at new buildings, what actually is being installed in new buildings, if the transformers are just standard, which I think is kind of what Bob Yanella showed us with what's being purchased, or if people actually are purchasing like a minimum a K-factor of 4, which I think they probably should, to just cover the harmonics that we see in our loads today. Mm-hmm. And if they're not, then that's going to be adding to the heating of the transformer.
Okay. Yeah, I agree. That's you know, again, it wasn't a focus, but that would be. We're in there anyways in terms of access to these facilities. Taking a measurement reading on harmonics would be a relatively simple thing to do.
Okay. If it's just spot checking and not continuous monitoring, how often do you think that should be done to be adequate? Do you think, you know, do you think like twice is enough at the beginning and the end of the project, or do you think that it should be a monthly thing, or what do you think? I mean, you're the expert.
Probably at the beginning and end. I mean, harmonics is not going to change all that much in terms of...
I agree with you, but I just want this to be a solid project.
Yeah, I mean, it's not going to change it much. I think once at the beginning and end is kind of a basically overkill. Maybe halfway through the project to visit each one of the sites and do a harmonics recording would probably be adequate.
Okay. Other questions I have for you, just as far as my sort of idea about building selection. You told me 40 samples, and so what I set up was kind of 50 commercial office buildings, but for a university study, you know, there's so many different types of spaces. I thought it would also be very nice, and this is what the sponsors kind of agreed with, is that we included some other spaces like residence halls and laboratories, but I didn't see the need to add so many, you know, places to monitor. So what I basically did was like 50 office buildings and 25 residence halls and like that. If you thought that that was enough if that would be like enough residence halls, or if you thought that was inadequate.
No, I think that's fine. Again, I'm looking at, you know, statistically what's going to come out as an outcome of this data collection. I think 50 sites, and also I like the way you've distributed the environmental characteristics into different categories.
Okay.
So I'll volunteer to go down and put the measurements meters in Hawaii.
I don't blame you on that one.
And actually, I'll go to Fairbanks. I'll go to Alaska too, but that's beside the point.
Okay, well, I think that if you don't have any specific comments about anything lacking in the selection of the buildings, the monitoring equipment, I'm hoping that Mike is going to connect me with someone I can start working on that. Site monitoring.
So if you're going to focus on newer buildings,
right?
I keep going through the you know, round and round of my, in my head, and you know, thinking about the newer buildings and thinking about and I'll just kind of do a brain dump just so you can know what's going on inside of my head, and then you can take that with a grain of salt. I think what you're going to find in newer buildings is they're going to follow the code, the NEC code. So they're going to be designed. They're going to be new enough so that they're not. They'll probably have 100% of, or we'll say 90% of their anticipated characteristic load for the facility. They're going to be designed to the NEC code and the standards, and you know, designed adequately with the load distribution. I think that's what you're going to find in buildings that are probably 2, maybe 3 years old.
I guess you probably would with universities, but what I found looking at plans in Georgia is that engineers are not designing to the lighting requirements in the NEC. And I also just
I think that's because the NEC code is a suggested standard. I guess, is that correct? Is that correct terminology?
I don't think it is. I mean, supposedly if the authority having the jurisdiction has adopted it, then it should be enforced. But again, you know, we're looking at, there are also energy codes. And so when you start looking, and I'm not really that familiar with it, with all the LEED certifications and all those other things, that they are complying with energy codes. And another thing I noticed just looking at plans is that I've seen plans that they're not complying with the receptacle load demand factor. They are doing the 180 VA or higher, depending on the usage, but when it goes to the 10 kVA per panel, plus 50%, I've actually seen plans where it's just 50% and not 10 kVA, plus 50% of the remaining load.
I understand. And that, I guess what I'm getting at is that if we look at older buildings and older facilities that are, say, 5+ years in age and nature, will that give us a better view of the type of load characteristics we're going to see on these transformers, not only on the distribution but on a download side? Will that be a better way of assessing where we should be moving the NEC code to, instead of looking at newer buildings? Now, there's a risk here, because I think the older buildings, you're not going to find the monitoring capabilities and the energy efficiency that you're going to find in the newer buildings. So I think we need to, I think in that approach, we're going to need more of installation of monitoring metering devices, more so than the newer buildings. That's kind of a brain dump where I'm coming from.
No, that's something to really think about. Another problem if we had older buildings would be then we're going to have to be concerned about the distribution and the study of old buildings and new buildings. But the other thing that even doing the study now is that major changes are occurring in lighting technology. And in the past 10 years, it's been pretty efficient fluorescent. But now we're at the brink that I think that things are going to start significantly shifting to LED.
I agree.
I mean, I've seen some LED lighting, but you know, in 5 or 10 years, it might be all LED lighting. I don't know.
Well, you look at a 50,000 square foot facility, and you look at the reduction of 50 to 75% of just your lighting load. That's a significant, not only energy savings, but significant dollar savings.
Oh, I understand that.
By the way, Linda,
actually,
I'm sorry, Linda. Tammy, what is your 1 or 2 numbers to describe across the board percentage loading on these transformers? Based on your export, you've seen what you've seen, and what are the loads? What are your studies? I know you've done a lot of research on this. I can't believe you did this. It's a lot of work here, and I will say so. What is roughly your experience of what the measured load from the studies has been? What is it?
Well, basically, the only definitive study I can quote for you right now is the Cadmus, and that was like 12 to 17%, and those were transformers 300 kV kVA and lower.
Yeah.
And I
loaded
think
at 12%. Is that what you're saying?
The average is like 12 to 17%, and the average peak load was only 33%.
Yeah, and of course, this is, this more or less conforms to my experience. And the manufacturers, like Bob, I respect his expertise, and we're going to have to use it, is that, okay, the transformers operate best hot, but that downstream equipment, those panels, those conductors, the space, everything, even the air handling systems that are sized to the maximum heat output of the transformer, all that stuff figures into it. That's what makes this.
You're absolutely right, Mike, and that's the kind of issue I'm getting to, focusing on the transformers themselves, because if in fact we are seeing across the board, just like Tammy has done her research on, if we're in fact seeing the 12, and I'm seeing that in the government side, I see that all the time. I see UPSs loaded at a 15%. It's not an efficient way to operate these pieces of equipment. So the question is, if we focus on these items and we look at the distribution, we can then make recommendations, or maybe even another data collection effort, but make recommendations to downsize the lower infrastructure.
One thing that amazed me, Bob, is that the average watts per square foot of an office building is less than 2 watts per square foot. That's average loading, obviously. That's not peak loading. But what we're looking at is the NEC is requiring design to 3 watts per square foot. I mean, they've just included a couple of exceptions. But so a building is truly being designed for, you could even say, 25 VA per square foot, but the average utilization is so much lower, and I think even the peak utilization is so much lower. And
you know what we designed the Pentagon for in the office areas, certain office areas? 15 watts per square foot.
I'm sorry, is that watts or VA?
Watts.
Okay.
15 watts per square foot. The utilization there, and I haven't measured it, probably 5 or 6 years, the utilization there is probably 1/3 of that.
Yes.
Well, no, wait, is that a data center is that a data center?
That's an office, the office areas.
Okay.
That's not the data center.
Well, that's insane. They probably wanted to run World War III out of any one of those offices. Well, okay.
I mean, that just gives you an idea of the different design characteristics that they're looking at.
Yeah, yeah. Can I add a little something here? I'm going to need the screen, though, Tammy. Is there something? Is there something here?
No, let me stop sharing.
Okay, so I'll take it over. I want you to see. I always like to remind people on these calls what the target is.
Well, if you don't mind, I'd like to talk in a little more detail about what you both think about doing studies on all building ages instead of just new buildings. To me, I just thought that new building was very clear-cut, because that way we would see definitively, have our best comparison with NEC design requirements and what we actually have in newer buildings. Because older buildings have older technologies and all kinds of, changes over the years. And then, of course, the complexity of how do you represent across uniformly across the board a wide range of buildings. So what do you really think, Bob and Mike, about opening this study up?
Well, okay, and that I have a partial answer for you. And it goes back to this table. You can see this table?
Yes.
So this is where I've been working for about 6 years with others. This was a change up here that came about just this year, and it deals with banks and offices only.
Right. You reduced the requirement by 1 watt per square foot.
Right. And also the change that we did in the previous 2014 cycle is this exception right here, which has a lot of... Okay, so there's that. I believe that the sentiment of the committee when I was there is that this entire table, which describes occupancies, which may be key to the building code or fire safety perspective, certainly not energy management perspective, that
No,
occupancy
it's not.
classes need to be revised. I usually point at schools. What do you mean schools? The classrooms with kids under 18? Is that a technical school with people who are doing continuing education over 18? All this kind of stuff. Classrooms, where's classrooms are not on here. Turns out in higher ed, most of the space is commercial. So this is a target area and one that could inform some of your approaches. Now, if you look deeper into this code, you'll see that many other industries have come and tried to get exceptions to this. You have the hotels, you have the restaurant folks, you got the shop lighting people in here. Everybody wanted to get an exception because it wasn't working for them. So it may be possible to just limit and because it's the education industry that seems to be taking the lead on this, unless, of course, the Department of Defense wants to help, that some consideration be given to maybe only dealing with a small set here and continuing the incremental change, which is more likely. So I hope that perspective might enlighten some of your thinking. So I'll shut up for a while, and I'll turn the screen back over to you, Tammy.
Well, that's okay. I mean, Bob is familiar with my report, and I really appreciate that, so we really didn't need to cover anything. One of the things I also wanted to bring up, just talking about the NEC in general, is I know you have the idea that what you want to do is you want to reduce the 180 VA to 120.
Right there.
Yep.
It's not everywhere. We may even consider another table where 180 is okay
right.
in hospitals, but 90 is okay in dorms and 120 is elsewhere. You know, this here itself could be scaled a bit.
Well, actually, I agree with you. It's going to depend on occupancy, but at the same time, I wanted to see if you just kind of open up your own thinking that, you know, perhaps what we mainly not need to be looking at is focusing on the 180 VA, but the demand factor.
Yeah, that's a very good point, Tammy. That's a very good point.
Just things to keep in mind.
So you say that the 180 VA could be informed by demand factor?
Yeah.
Okay.
Yeah, I mean, basically what we have.
I feel a proposal coming on.
Well, basically,
yeah, I mean that's a good point because you have so many diverse type of applications. Why would you pigeonhole a design characteristic when it's really it's dependent upon the load factor? You have to be calculated.
One thing I'm concerned about as far as the 180 VA requirement is that we can have these statistical averages and run these studies, but you really don't know what some kind of nut in charge of a whole branch circuit is going to do. That I think that you're still going to require the same amount of wire, and I don't know if you're concerned about the copper conductor size that you're going to have to install, but I think it would be safer and a lot more sensible to leave the 180 VA, for example, where it is, and just look at what you need as far as at a panel level, and not say, well, 10 kVA but 50%, but just what I think we should do, which never happens, is instead of trying to like cut and paste the NEC requirements, is we should look at what we think needs to be done 50 to 100 years later, instead of just trying to keep cutting and pasting what's been done for the past 50 to 100 years. So what I'm suggesting is, you know, actually doing this study and then making proposed code changes on what needs to be done at this point, and not modifications of existing code.
Well, yeah. Pathologically, I'm not able to do that, Tammy. That's sort of a joke. I like to throw stuff up in the air and see what sticks to the wall, or throw it at the wall and see what sticks. There's lots of naysayers. This is an industry. The standards business has an oversupply of veto points. But if you get one through, usually you're okay. But I agree with you generally that it's probably more palatable to certain industries Now remember, most of the resistance is going to come from industries who are going to lose money. They're getting sent to these meetings and supported to advance their economic agenda. That's why it's so hard to get manufacturers, except for heat.
Yeah, that's true, Mike. That's absolutely true. But if you listen to what Tammy is saying, if you change the code, no, I shouldn't change the code. Add to the code the demand load side of it. That is not necessarily, the economic portion of that is not necessarily true.
Well, no. What it means is if you have a 50% demand factor, that 300 kVA is going to be 150 kVA. That's where it matters. So
right. I agree with you. But what about the flip side of that? What about if you have a particular application that doubles that size? It's going to be on the low demand factor.
Well, then we craft language that makes that possible also.
Yeah, exactly.
Yeah. So remember, they're a fire safety organization, not an energy and efficiency. But
I understand.
Yeah.
I understand.
Well, I think that
That's right. It's based on. It will be based on load characteristics and how best to match the load characteristics to the distribution.
Right. If you look here, look a little bit farther over here, you can see, just so you know, that this concept already has been captured in the show lighting area. Okay. So the concept, but since we have a scalable parameter here, the 180, which is an easy target, I agree. You can do something here. For general office loads and such and so forth. So it's a great idea, and let's get your name on that proposal, Tammy. I'll find out when the proposals are due, and I'd like you to put it out there even without data, because you have to you have to soften the beachhead a bit.
Well, first of all, I've spent a lot of my career looking at arcing faults, which you might know, but I'm really concerned because I've made my living investigating fires of electrical origin, and they're not necessarily occur in the branch circuit wiring, although some do, but a lot of fires occur in end-use equipment and branch circuits at very low-level arcing or overheating, whatever you want to call it, the glow connections and the whole 9 yards. And I think that you kind of extinguish the fire and concern about fire safety when you take the attention off the branch circuit where the fire actually occurs, and you look at it like at the panel level, which is supplying all of the branch circuits. Because I'm concerned too about, adding, 5 or so receptacles to each branch circuit.
Okay.
Anyway, I'm just trying to help you think things at a larger scale too, because we're really at an open slate here as far as what kind of code changes that you might want to occur at the end of this.
Well, we won't have a study done, phase 2, if we're lucky enough to get it. We won't have it done. We won't have it done before the proposals for the comments on the first draft report. But we can get close and we can ding the committee a little bit. I know who's going to vote against it, so just I know these guys are all good guys, all weaning guys, but they vote their book. That's why it's done.
Well, that's another really good point I want to bring up for Bob while we have him on the phone. That first of all, if you're going to attack the 180 VA, we need branch circuit monitoring. And what I've addressed in here, since I know that's important, is 2 months of branch circuit monitoring. But I was going to ask Bob, first of all, that's enough. But if you change the focus of your attack to the demand factors, then we can look at it at the panel level, and I think that might really help.
I don't know how you're going to monitor all those panels in these facilities. I just, on a realistic basis, I don't know how you're going to monitor all those panels.
But Tammy, you're the presenter now. Tammy, go. You just click it in.
That's why I'm saying, is it more proactive to monitor at the transformer, the distribution of these systems in terms of loads? Because you're talking about the 50,000 square foot facility, you could be talking hundreds of panels.
Well, when I look at office buildings, I don't really see that many panels on an office building. I see, maybe I'm guessing like 15. So that's not too terribly many, and I agree with you. It's a lot, and I don't know how it's feasible. And that's why I was surprised when I saw the energy code that said monitoring was required on those loads, because typically what I see, I don't know if this is smart as far as design, but a 3-story office building is going to have 3 step-down transformers, one for each floor. And basically what they're supplying is receptacle and then miscellaneous 120, 208 volt load. And so what I'm guessing is that these energy codes, they have to be monitoring more than I can conceive, because that's going to be more than just at the surface feeder. And I guess where we need to go right now is that I need to figure out, Mike, since you're into the standards, do you have connections with anybody who actually sees this monitoring or knows how it's being realized at a feasible level? And from what I've talked to, the limited amount I've interacted with the sponsors, is that they do a lot of monitoring, a lot more than they think should be done on lighting and receptacle load and where that's actually implemented.
Okay.
Okay.
So
right.
we have major work right now in how to make it happen. So
Well,
I think that
I'd like to be able to. I think one of the outcomes of this study is how we would craft a phase 2, and I'm not sure how many hours you've got on this, and that's why we have Bob here, because whenever Bob says he's concerned about data gathering and assembling something that's statistically significant, I usually jump, and that's what much of this call was about. And I think some of his concerns might have been addressed here. But in general, how do we get this set up so we can get funding, either from a combination of, federal, state, university, hospital facilities? Maybe I go to ASHRAE, maybe I go to IEEE. They rejected this, by the way. I went to IEEE for funding on this. They rejected it. So
Surprise.
you are surprised, or you're not?
I was being facetious. I was just saying surprise.
Oh, okay, yeah, okay. So maybe go to ASHRAE. We'll find some way. But I really want to set my sights on getting a phase 2 set up, and part of phase 2 might help clarify some of that.
Yeah, I think we need to focus on something that we can. I think Tammy has laid out. Tammy, you've laid out. I think what I would call a statistical, even in your your third version here. I think I would call that a good statistical sampling of information. I think what we need to focus on is I think what we need to focus on then in a decision of where we monitor. If we monitor just at the transformers, if we monitor at the panels, it's got to be something that's doable within. You're going to spend a minimum of 6 months just identifying the people and getting the people to agree to do this study, to open up their facility and do this study. You're going to spend the next few months just going crazy by installing the monitor, if we have to install monitors or installing the monitors, and then you got to have a complete infrastructure back to a central location that's going to be collecting this information every so often. You got to be, in the meantime, you got to be establishing a database to hold this information, and not only to hold it, but also to have the capability of statistically analyzing this thing. So there's a lot of infrastructure here. I can't see this thing getting done in any faster than 2 years. So there's a lot of things that we have to be conscious of and make sure that we collect as little as we possibly can to be as efficient as we can, but as much as we possibly can to get the answers we need. So that's a kind of a.
So we came up with $1 million and a half, 3-4 years ago. That's the number we were working on. Tammy, part of your scope is not really to estimate phase 2, is it? Isn't it just to validate that or confirm or deny the hypothesis?
No, I don't think it was really part of the scope. I think I might have seen it mentioned somewhere, but that's not really what I interpreted it to be.
No, neither did I. So really,
No, you're supposed to come up with
a lot
a
of
plan,
hours
right?
on this, but recycling what Bob knows from his experience with the reliability committee and putting together what a phase 2 might look like. So that might end up having to be off the chart, and how identifying funding sources, that's also not part of your scope. But the outcome, I think it's fairly clear right now that it's something that we need to look into for all the reasons we thought. Is that?
Well, I think part of the scope is to lay out a basic plan. Is that right, Tammy?
Yeah, I mean, part of the scope is the plan, and then part of the scope is the background research, which I've really spent an extensive amount of time on that, and I have quite a bit more than that I want to do, honestly, because I just want to completely cover all of the factors in the branch circuit and the feeder loading, in addition to the energy codes and the plug studies, what they're seeing, and it's just the transformer loading. There's just so many things I'm trying to bring in. And then, of course, I covered the different types of loading in different buildings to just try to help us think about all of the things that are playing, not only with what we're seeing in buildings, but the factors around the country that are motivating. The differences between what the NEC is demanding and the energy codes. There's just so much dichotomy.
Okay, so Bob, how about we start conducting separate discussions about crafting a proposal for phase 2. I'm going to be at the NFPA conference in June. I've got a proposal out there, and I'm going to be at Boston in January also on another facility manager project for NFPA. So I'd like, Bob, you and I, we'll invite you, Tammy, as to how we would craft this so that it looks like we have the possibility of the DOD funding or the Army Corps of Engineers, or where some of your funding sources have been in the past when you're doing IEEE work.
Okay.
Yeah?
Yeah, okay.
Well, what about EIA? I mentioned that because I thought it was very significant that they run these CBECs every 3 years, and they cost in the tens of millions.
Oh, yeah.
And what they really need, and what they're doing is all their end-use loads are estimated. They have the measured load, of the site, but they project all of these calculations about what the end uses are, and they have no idea really. And I mean, I thought, well, why not approach them, because that's what they really need.
Okay, well, we can't discount any sources, but I will still hang my head on Bob as being the best data gatherer in the land.
Oh, of course. Well, this is just for funding.
So I think if I had one recommendation about your paper, Tammy, I think that if you get to it to the point where maybe a brief section where you had a graphic that you would show what and it could be a one-line drawing, but graphic where you show where we would place monitoring devices, suggested monitoring devices. I think that's probably the only recommendation I would have on this paper. I think it's very good, very well written, by the way.
We actually already have one like that. We did it actually for the code, but it would take somebody 10 minutes to do it, or you can do it by hand. But I know what you mean. I know what you mean. And okay. Yeah. Are you, Bob? So, are you comfortable with the approach that is being recommended here, or are you comfortable with taking the next step, even if you aren't comfortable with the approach?
No, I'm comfortable with the approach. I just would like I said when I started, a little bit more detail about what items you're going to collect the information on. How are we going to focus this thing down to a reasonable data collection effort for a 2-year period? That's the only thing. I'm very comfortable with how she's written everything out. I shouldn't say. I'm talking to you, Tammy, like you're a third person. No, like Tammy has written.
No, I appreciate it, Bob. And what I needed anyway was direct feedback. So, you know, if you have anything that you really like to criticize, you know, I'm open, because that's the only way this is going to improve what I've done here.
No, I think you've identified a good statistical approach in this thing. I think it's very aggressive. I think, again, I think it's going to take at least 2 years to do, but I think what's lacking is the specifics, plan, layout of exactly what we're going to collect, what items we're going to collect the information on.
Mm-hmm.
Okay, well, we'll see what we can come up with.
So, Bob, with Harris Corporation, is this, tell me what the extent of your involvement. I'm assuming, Tammy, if a phase 2 is let out, that you have the time to manage a project like that. Now, remember, you have to go through the whole process with NFPA, but that you're going to be involved in phase 2 no matter what. How, for example, would Bob and Tammy work together on this, and in what capacity is Bob able to under Harris and or with IEEE?
Let me give you an example. The last data collection I had for the Army, it involved 2 years, $2 million. I had 3 teams. I had 2 teams of 2 people that would alternate travel for the 2 weeks. It took us 6 months to resurrect, and from our previous data collection effort, it took us 6 months to resurrect the names and go after the same facilities that we had in the previous 4 years before. There was a series. It's a whole process. I have a whole process written up. There's a series of data calls that we'd have to get permission, and then there was the travel involved with my 2 teams, and then there was a data collection effort back in home. So I have that. It's a pretty extensive process, but I have that whole process written up in a report.
Could you, so when I go to NFPA or even before then, I'd like to, I'll start campaigning for a phase 2 as a member of a couple of other committees. At any point, I can start a phase 2, and I think Casey has even recommended that we move ahead. At least I move ahead a bit on that. So I'm assuming that if I start to craft a proposal for phase 2 and then a budget, that both of you will have time to add input. I'll do what I usually do: get a Google document going, and share it with you. And we start putting man hours, travel.
And I would seriously consider, Mike, that you go after $2 million.
All right. This will be the largest project. This will be the largest.
And get what we get. And we can always scale it back, but get what we get. Maybe we can't go to all 50. Maybe we go to 40. Maybe we go to 35. I don't know. Mm-hmm. But get what you get. At least that's based on my experience.
If I were to propose IEEE, ASHRAE, and NFPA to do this with the DOD, you know, ASHRAE is going to want to be in here because of energy management. I get that. IEEE wants to get in here because of engineering. NFPA wants to get in here because of fire safety. So I think I have all bases covered if those 3 organizations feel like they're part of this. And of course, we'll be doing for government money.
Personally, I wish you could get the EIA involved, because they need the data more than anybody else. Not that I think that they'll necessarily realize it.
No, that's what I mean. You're talking about the Energy Information Administration?
Uh-huh.
Yeah, that's what I mean by the government generically. There's got to be 10 departments that would like to be in on this. So I'll just generically call them the government. And I know Rich. I don't know him, Eric from PNNL, and he seems very collegial. So they know my name out there. I've got stuff through them, ASHRAE, so I'm a familiar name in their transcripts.
Well, if you excuse me, I have to drop off for yet another telecom. Okay. It's just a stimulating conversation. I enjoyed it. But let's get together again here pretty soon. Of course, we're going to have a meeting on the 15th, right?
Yeah.
Yes, we do.
Okay, so we probably ought to touch base before then. If Mike, if you're available and can set something up.
Sure. Yeah.
But I have to drop. I'm sorry.
Okay.
Sounds good. Thank you.
All right. Thank you.
let's see, Tammy. I made you the presenter. You didn't accept.
Oh, I'm sorry.
I wanted to close out on your. I wanted to close out with your screen on there. You just have to say yes. No? Okay, I'll take over then. I'll close out the call.
Yeah, for some reason it wasn't responding to my share. Okay.
Show my screen. Okay.
Well,
Well, all right. So I'll
very
focus on the
productive.
project website. It won't be NFPAs. It'll be the IEEE one for the moment. And I'll start. I'll start sending up flares on participating organizations, utilities departments that are willing to turn over feeder data, feeder and branch circuit data. It'll just be, try balloon, see what we get, and that might help some of our. Maybe we'll get. Who knows what we'll get before November 15th, but that'll give us a first cut sense of the interest in this.
Okay.
Okay, I hope it sounds to me like you've been bit by all this.
Oh, it's really interesting.
Yeah, it's taken most of my career to get people to see this. I just got back from Washington, and one of the old party war horses got an award, and he said, you get bit by this stuff, and those of you who are passionate about watching paint dry, we have to bring up a new generation of standards experts. So I thought, I was thinking about those of us who labor here, usually in the background. Nobody knows, we'll know 100 years from now how it got to be. The code will change. And we'll build on what we know. So anyway, that's my way of saying thank you, Tammy.
Well, let me tell you what I did with Annex K in 70E. I looked at that and I thought, this needs to be rewritten. And it doesn't need to be changed here or there. It just needs to be entirely rewritten. So I rewrote it. And the committee laughed at me. And so they said, well, of course, I know delete. And so he said, well, if you want to make changes, you have to publish a paper. So I wrote a paper that contained how I thought Annex K should be rewritten. And not specifics. I just rewrote it for them. I said, this is the suggested content for Annex K, and this is my field of expertise. So, it was extremely well referenced in the whole 9 yards. And I haven't seen it, but everyone, of course, stuck their oar in and criticized it on this or that. But because of that, it has been rewritten. It wasn't my content exactly, but I'm hoping it will look pretty good. So
right,
I think
here?
we should do something like
this one here?
Mm-hmm.
Yeah.
Yes.
Okay. All right.
So it'll be interesting to see, what it looks like when it's published.
Do you want to do a talk on this? A separate talk? You busy enough?
You mean for your education and healthcare committee?
Yeah.
I will, but not right now. How about,
Okay. That's good.
We will do it.
That's the correct answer. Thanks very much for your time, Tammy. I'll see you at the very least when Bob and I find that we get a budget together. You'll share it, and we'll find it. Actually, let's do that right now. Before the 15th, let's see. And that's when I will, let's see here. I'm working off 3 email accounts. Let's look at what time slot. I'm just wondering. That's the 15th. That's this. Geez, there's not a lot of time. It's just right here. I'm going to send up something. I'll send up. I think I'll do something right. No, I'm going to be in Chicago. Well, it looks like it's going to be at 2 o'clock on next Thursday. What does that sound like to you?
That sounds okay to me.
Oops. And what did we say? Say 2 o'clock. 2 to 3. Okay. All right. I'll see you at the very least next week.
Okay.
Yep. Take care.
Good week.
Thanks for your time.
Bye-bye.